Hey everybody. Today we're going to do a few harder problems using the first fundamental theorem of calculus. We're going to do 3 of them. Here they are. These are all pretty typical of problems you run into in calculus 1. So to start, integral from x to 3 of some function. The problem here is that the x is in the bottom limit of integration, not the top. So in order to differentiate that, we first have to flip the limits of integration around. Property of definite integral says we can do that by introducing a negative sign. So we do that, apply the first fundamental theorem of calculus by just plugging in that upper limit of integration, x, into the integrand. Overall, negative x to the 5th minus 2x squared plus 1, all to the 7th power. Bottom line, if you've got the variable in the bottom limit of integration, you got to move it up top and introduce a negative sign. Problem 2. Integral from 1 to x squared tangent of t cubed dt. So at least the variable's in the right place here in that upper limit of integration. But now it's not just an x, it's an x squared. So we've got a function of a function. If you were to evaluate this, first you would plug the number x into x squared to get your limit of integration, and then you'd find the area under tangent of t cubed between 1 and that x squared. So the way we're going to differentiate it is with the chain rule. We're going to differentiate the outside function first, that integral. We're going to plug that x squared into the function tangent of t cubed. And then we're going to multiply by the derivative of the inside function, so by 2x. Okay, so let's actually do it. Here we go. First, I have plugged the x squared into the integrand, tangent of x squared to the 3rd power. Then I've multiplied by the derivative of that x squared. Tangent of x squared to the 3rd power times 2x. Rewriting that in a slightly neater fashion, 2x tangent x to the 6th. Problem 3. This is definitely the hardest of the 3. Now we have a function in the upper limit of integration, just like before, but now we've got another one in the lower limit of integration as well. So we know having x's in the lower limit of integration is a no-no when it comes to the first fundamental theorem of calculus. So the first thing we're going to want to do is to handle that. And we're going to do it using another property of the definite integral. The integral from a to b plus the integral from b to c is the integral from a to c. Basically, areas under graphs add. So let's rewrite that integral. Instead of going from negative 2x to x squared all in one go, let's go from negative 2x to some number a, and then from a to x squared. So the whole thing in the brackets there is actually equal to the integral from negative 2x to x squared, 1 over 1 plus t to the 4th dt. Okay, great. Next thing I've got to do is deal with the fact that I have variables in the lower limit of integration in that first integral. So I'm going to flip those limits around and introduce a negative sign. Now finally, I'm ready to differentiate. I'm going to use the chain rule. I'm going to use the chain rule on each of those 2 integrals. So in the first case, the negative sign is coming along for the ride, and then I'm going to plug in the negative 2x right into that integrand function, 1 over 1 plus, parenthesis, negative 2x to the 4th. Then I'm going to multiply by the derivative of the negative 2x. That's where that negative 2 is coming from. For the second integral, when I differentiate it, first I plug in the x squared, 1 over 1 plus x squared to the 4th, and then I multiply by the derivative of the x squared times 2x. Simplifying that a tiny bit, I'm getting 2 over 1 plus 16x to the 4th plus 2x over 1 plus x to the 8th.